All right, so it's a pleasure to welcome our next speaker. It's Dennis Spellman, and he's going to give a talk, also at least partly on behalf of Tony Gaglioni, whom we can see there in the back of the picture. And it will be a talk about remembering Gilbert and Ben. Dennis, please.
Okay, well, I'm saddened by Ben's passing, but happy to have this opportunity to speak a little bit about Gilbert and Ben. Gilbert invented the technique of big powers. This can be considered a small but not insignificant first step toward the solution of the Tarski problems. Gilbert's brother Benji, in a pioneering paper, elucidated the role of commutative transitivity. Almost implicit in Benji's paper was a characterization of the universal theory of any non-cyclic free group, although Benji was unaware of that connection. To finish the job, one needs the development of algebraic geometry over groups, and the fact that free groups are equationally notarial. These facts were established by Gilbert, Alexei, and Remeslenikov. There being a method to our madness, we state the result for the rank 2 free group F. The universal theory of F, in the language of F, is axiomatized by the quasi-identities true in F, together with commutative transitivity, when the models are restricted to F groups. Alexei posed us the question of whether or not the analogous result holds for the free rank 2 nilpotent of class 2 group H, also known as the Heisenberg group, if commutative transitivity, which of course can't hold in a nilpotent, non-abelian nilpotent group, is replaced with non-central commutative transitivity. That is, if two elements commute with a non-central element, they have to commute with each other. We cannot resist announcing here that we have answered Alexei's question in the positive. Recently, we posted on the group pub forum an obituary for Ben Fine. Let me interject something here. This talk is going to be a little more lighthearted than the other talks. I was told to give a non-technical talk, so you'll forgive me if it sort of differs in tone from some of the other talks. It was edited to cut, the obituary was edited to cut it down to reasonable size. This venue gives us a chance to mention some of the deleted material. Ben was a senior tennis star, top ranked in the state of Connecticut in that category. He was a fun-loving individual who once played piano in a piano bar. Besides that deleted material, we mentioned that Ben, of the Jewish faith, got along famously with the clergy at Fairfield University, a Catholic institution. In fact, he related that an order of monks had asked him to convert and join them. He replied he was willing to, provided they let him out every 2 weeks to, well, this talk is rated G, so we'll ask you to use your imagination. The monks said they didn't think he was appropriate for their order. This was a big tongue-in-cheek for Ben, was a faithful husband and devoted father and grandfather. Ben once invited me to give a talk to undergraduates at Fairfield. My topic was killing flies with hammers. Since then, I've dreamed up other examples. The other examples, from the fact that finite groups are hyperbolic, one concludes they are finite presented and have a solvable word problem. My favorite was a proof I learned in prehistoric times as a grad student in Martin Davis's class, using the compactness theorem of model theory, that -1 is not the square of a rational number. One needs the following 2 facts from number theory. There are infinitely many primes of the form 4k plus 3. If P is an odd prime, then the congruence x squared congruent to -1 modulo P has a solution if and only if P is of the form 4K plus 1. Now write down the field axioms. The sentence P is different from 0 for each prime P. And the sentence for all x squared plus 1 is not equal to 0. Now, any finite subset S of this set of sentences contains only finitely many sentences P unequal to 0. Choose a prime Q of the form 4K plus 3, larger than any P such that P not 0 lies in S. Then the Galois field of order Q is a model of S. So there must be a field K of characters 0 such that x squared plus 1 has no root in K. Hence, x squared plus 1 cannot have a root in the prime field of rationals of K. Of course, this series theorem is implicit in this joke. Namely, if a first order property of fields holds in a field of arbitrary large prime characteristic, then there must be a field of characteristic 0 in which it holds. Okay, I thank you for this opportunity. I hope you enjoyed my little talk.
All right, that was pretty fast. Thank you, Dennis.
You're welcome.
Thank you.
Thank you. If anybody has any comments or questions, so you're welcome to speak up. So I had a question, maybe possibly Gerhard also, can say something about this. As I recall, Ben was also a writer, right? He wrote.
Yes. Yes.
So, can you tell us a little bit more about what he was writing about and where it was published and how many things he wrote? I think some of that had to do with pirates. Is this correct?
He wrote short stories and fiction. He had a couple of novels.
He had at least 2 novels.
Yeah, he had at least 2 novels.
And they were published, right?
Yes, and they were published.
You don't remember where, on what they were about, so.
One was about, I think, the Inquisition, and another was about a right-wing political plot.
Interesting, very interesting. Okay.
His short stories were about his adventures as growing up in Brooklyn, New York.
Yeah, in Brighton Beach.
Yes.
I see. Okay. All right. Thank you once again. So I'll stop the recording now.